Hello everyone, in this video we will explore topic 5.4 using the first derivative test to determine relative local extrema. Alright, we have new vocabularies. Extrema is the plural form of the extreme, meaning all maximum and minimum values. Minima is the plural form of the minimum. Maxima is the plural form of the maximum. Now, the first derivative. We have the theorem, the first derivative test. Let C be a critical number of the function f that is continuous on the open interval I containing C. If the function f is differentiable on the interval, except possibly as C, then f of C can be classified as follows. Number 1. If f prime of s changes from negative to positive as C, then f of C is a relative minimum of f. Alright, so you're going to sketch the diagram like this. Suppose the interval I is A and B, right? And C1, C2 inside the interval A and B. And suppose the function f prime of s changes sign from negative to positive as C1, which is the first one right here, right? I call this is C1 and f of C1, right? And from positive to negative as C2, which is the second case right here. Positive to negative as C2 and this one f of C2. Now, since f prime of s is negative, the function f of s is decreasing, right? And this one, the function f of s is increasing because f prime of s is positive right here, right? And similarly, this one is decreasing, right? So you have the relative minimum right here and relative maximum right here, right? Which is right here, right? Now, number 3. If f prime of s does not change the sign as C, f of C is neither a relative minimum nor relative maximum, right? You look at the picture right here, number 3 right here. The sign does not change. Look, f prime of s greater than 0 the first time, f prime of s greater than 0 for the second time, and it doesn't change sign at all. So neither relative minimum nor relative maximum in this situation. Or if it's negative, it's still negative right here. You see that? It's going down. And this guy going down. Right? Remember the Christmas tree trick. If the tangent lines go this way, the slope is positive. Tangent lines go this way, slope is negative. Right? Only the first two cases right here, the slope of the tangent lines change sign, right? Negative to positive, right? It's going to be like this. So this one is minimum. Positive to negative. This one is maximum. Now let's take a look at the first example. Apply the first derivative test. A. Find the points that are relative extrema of the function f of s equals 1/2 s minus sin s on the interval 0 to 2 pi. Alright, so what you need to do is to find the first derivative, right? So we have f prime of s is going to be 1/2 minus cosine s, right? And you let the first derivative equals 0, right? And it's going to be 1/2 minus cosine s equals 0, right? This guy is the same thing as cosine s equals 1/2, right? Now remember that the domain is from 0 to 2 pi, right? So this guy turns out to be s equals pi over 3 and 5 pi over 3, right? Now you're going to sketch the diagram, right? So I'm going to pick pi over 6 right here. Within this interval, right? I substitute pi over 6 for s into f prime right here. Right? Because I need to check the sign of f prime of s, right? So this guy turns out to be 1/2 minus cosine of pi over 6 equals root 3 over 2, right? So observe that this guy always negative, right? So then this interval becomes negative and you keep changing the sign. This one positive and this one negative, right? And the function decreasing within this interval, increasing within this interval, and decreasing within this interval, right? And right here you have the relative minimum and you have the relative maximum here, right? In order to find the points that are relative extrema, you need to substitute pi over 3 for s back to the original function right here, right? Because you need to find the value of f of s right here, right? So you have 1/2 times pi over 3 minus sine of pi over 3, right? So this guy turns out to be pi over 6 minus sine of pi over 3 equals root 3 over 2, right? I need to simplify this one, right? So this guy turns out to be pi subtract 3 root 3 over 6, right? So this guy turns out to be pi subtract 3 root 3 over 6. Now similarly, I need to substitute 5 pi over 3 for s into the function f of s right here, right? So I have 1/2 times 5 pi over 3 minus sine of 5 pi over 3, right? So it turns out to be 5 pi over 6. Sine of 5 pi over 3 equals negative root 3 over 2, and combined with the negative side right here, it becomes plus root 3 over 2, right? Now I need to simplify this guy. It turns out to be 5 pi plus 3 root 3 divided by 6, right? So this guy turns out to be 5 pi plus 3 root 3 divided by 6, right? Alright, now last but not least, you need to conclude, right? Now keep in mind this table right here is the one that helps organize your thought. It's not the work you need to show on the AP exam, right? So on the AP exam you need to write the function f of s has a relative minimum pi minus 3 root 3 over 6 at s equals pi over 3, because the function f prime of s changes from negative to positive at s equals pi over 3, right? Similarly, you need to say that the function f of s obtains the relative maximum 5 pi over 6 plus 3 root 3 over 6 at s equals 5 pi over 3, because the function f prime of s changes sign from positive to negative at s equals 5 pi over 3. Now let's move on to question B. Find the points that are relative extrema on the function f of s equal this one. Alright, first you need to calculate the first derivative, right? F of s. It turns out to be 2/3 times s squared minus 4 times 2s, right? You need to use the chain rule. U to the n prime equals n times u to the n minus 1 times u prime, right? So I'm going to simplify this guy. It turns out to be, oh, I forgot this one. 2/3 subtract 1 is going to be negative 1/3, right? So this guy turns out to be 4s over 3. I bring this one down to the bottom. It turns out to be cube root of s squared minus 4, right? You need to find the critical points. So in order to find the critical points of f prime of s, remember you learned before, it is where f prime of s equals 0 or undefined, right? Now if f prime of s equals 0, then 4s equals 0, right? So then s equals 0. If f prime of s is undefined, then the denominator equals 0, right? Which means s squared minus 4 equals 0. Then s equals plus and minus 2, right? Now you need to draw the diagram. Alright, so write at s equals 0, at prime of s equals 0, right? So you need to put a 0 right here. Write s equals plus and minus 2, right? F prime of s is undefined, right? So you put 2 lines right here. Alright, now you're gonna check the sign, right? You're gonna pick a number within any intervals, right? So I'm gonna pick 1 right here, right? I substitute 1 for s back to f prime of s right here, right? I need to check for the sign, right? So I have 1 square minus 4 is gonna be negative 3, right? So this guy becomes negative number, right? So within this interval it's gonna be negative sign, right? Now you keep changing the sign. This one negative, this guy positive, this guy negative, this guy positive, and this guy negative. Or you're gonna test. If you pick 3, you substitute 3 for s over here. It's gonna be 9. 9 minus 4 is gonna be 5. It's positive, right? So this guy positive, this guy positive. Now if you pick negative 1 over here, right? So you substitute over here, negative 1 square is gonna be positive. Positive subtract 4 is gonna be negative, right? Now negative multiplied by the negative number right here, it becomes positive. So that's why you have positive right here. And last one, you substitute negative 3. Right, so it could be 9. 9 subtract 4, it could be positive. And this one is negative 6, so it becomes negative, right? Now, if f prime of s is negative, the function is decreasing. This one, f prime of s is positive, the function is increasing. This one, function is decreasing. And this one, function is increasing, right? And you have the relative minimum right here, relative maximum here, and relative minimum right here, right? And you substitute negative 2 for s back to the original function right here to solve for f of s right here, right? So I have negative 2, substitute over here, it's going to be 4, 4 subtract 4, it's going to be 0, so this guy equals 0, right? Similarly, 2 is equals 0, right? Now relative maximum, you need to substitute 0 for s, right? It's going to be 0 squared minus 4 raised to the 2/3, right? So it could be negative 4 all together raised to the 2/3, right? So it's going to be cube root of negative 4 squared, right? So it could be cube root of 16, right? So right here you have cube root of 16. Alright, now you can give a conclusion easily, right? Based on the diagram right here, you can say that f of s has a relative minimum of 0 at s equals negative 2 and 2, right? Because f prime of s changes sign from negative to positive at s equals negative 2 and 2. Now, similarly, the function f of s has a relative maximum of cube root of 16 at s equals 0 because the function f prime of s changes sign from positive to negative at s equals 0. Now let's move on to question C. Find the points that are relative extrema of the function f of s. Now we need to find the first derivative, right? So f prime of s equals, we need to use the quotient rule, right? So it could be u over v prime. It's going to be u prime v minus v prime u over v squared, right? So this guy turns out to be 4s cubed times s squared minus 2s times s to the 4 plus 1 over s to the 4, right? I'm going to simplify this one. It's going to be 4 s to the fifth minus 2s to the fifth minus 2s, right, over s to the 4. So this guy turns out to be 2s to the fifth minus 2s over s to the 4. I need to divide the top and bottom by s. So this guy turns out to be 2s to the 4 minus 2 over s cubed, right? Now I need to find critical numbers, right? Remember, critical numbers is where f prime of s is undefined or equals 0, right? Now f prime of s equals 0 when the numerator equals 0, right? So it could be 2s to the 4 minus 2 equals 0. If you solve this one, s equals plus and minus 1, right? Now f prime of s is undefined when s cubed equals 0, then s equals 0, right? Again, you're gonna sketch the diagram, right? Alright, so f prime of s equals 0 when s equals plus and minus 1, right? So this one equals 0, this one equals 0. Look, f prime of s right here, right? Now f prime of s is undefined when s equals 0, right? So you're gonna put 2 lines right here. Alright, now you're gonna test the interval, right? So within this interval, I'm gonna pick 2, right? I substitute 2 for s into f prime of s, which is right here. Alright, so I have 2 times 2 to the 4 minus 2 over 2 cubed. This is always positive, right? So this one positive. Then you keep changing the sign, right? So it could be negative, positive, and negative. This guy negative, the function is decreasing. This guy positive, the function is increasing. This guy negative, the function is decreasing. And this guy positive, the function is increasing, right? So based on the diagram, you have the relative minimum right here, right? This guy relative minimum right here. Now a lot of students could make some mistake right here because they're gonna say the function f prime of s changes sign from positive to negative as s were 0. So the function f of s obtains the maximum, right? But when you substitute 0 for s back to the original function right here, observe that the function is undefined, right? So this guy is undefined. Therefore, there is no relative maximum right here. You only have 2 relative minima. That's it, right? Now, to find the relative minimum, substitute -1 for s back to the original function right here, f of s, right? Because you need to solve for f of s, right? So -1 to the 4 is going to be 1. 1 plus 1 is going to be 2. 2 over 1 is going to be 2, right? Similarly, this one should be 2, right? So you need to conclude that the function f of s has a relative minimum at -1, 2, and 1, 2, because f prime of s changes sign from negative to positive at s equals -1 and s equals 1, right? And there is no relative maximum because the function f of s is undefined at s equals 0. Now we can bring up the calculator to check our work, right? So we're gonna go to question A right here. Now you need to add graphs, right? So you need to input the function right here, 1/2 s minus s, right? And you hit enter, it's gonna be right here. Now you need to restrict the domain, right? Domain is should be 0 to 2 pi, right? So you need to hit menu number 4 right here and number 1, right? S min should be 0, right? S max should be 2 pi, right? Which means 6.28. You hit OK, it's gonna be right here, right? Now you have one relative minimum, right? And one relative maximum, right? It's gonna be right here. Now I'm gonna hit menu, analyze graph, minimum here, right? And move to the left, to the right. It's gonna be right here, right? Relative minimum. Now similarly, I need to find the relative maximum. I need to hit menu, number, set relative maximum. Move my vertical line to the left, to the right. The answer is right here, right? Now for question B, I need to hit Control I, add graphs. I need to input s squared minus 4 raised to the 2/3, right? And hit enter. You have two relative minima right here, right? So you need to hit menu, number, set, and minimum. Move to the left, move to the right. It's gonna be right here, right? And similarly, menu, number, set, minimum, move to the left, move to the right, and it's gonna be right here. You need to find the relative maximum. It's gonna be right here, right? So menu, analyze graph, maximum, move to the left, move to the right. It's gonna be right here, right? Now let's move on to question C. Alright, I'm gonna hit Control I, add graphs. I'm gonna input the function. Hit enter. It's gonna be right here. Now observe that the function does not have relative maximum, right? Because it keeps going forever. You see that? You only have two relative minima right here, right? So you need to hit menu, number, set, minimum, move to the left, move to the right. The first relative minimum. Now similarly, menu, number, set, number 2, move to the left, move to the right. The second relative minimum, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in